Okay, the second example that we're going to be doing is a little more difficult than the last one. And the last video was just y equals sine of x, or y times sine of x. This time we're doing 1 plus x times dy over dx is equal to 4 times y. And the concept is the same. You have to separate the dx from the dy, and you have to get the x's on one side. You have to get the y's on the other, or the y's on one side and the x's on the other side. So that's what I did here. You divide 4 by y, you get 1 over y times dy on this side. And there's no dx here because you multiply the dx by this side. So they're separate now. Then you take the integral. I just want to make sure you understand what's going on, because 4 divided by 1 over x on the right hand side times dx, so our x's are all on the right side and our y's are all on the left side. Now take the integration. Now remember from the last video, if you haven't watched that, go watch that to understand this. This 1 over y, the integral of it, is just going to equal natural log of y, or absolute value of y. Natural log of the absolute value of y. And this is going to equal 4 times. So this might take a second to understand, but remember that if this equation was 1 plus x, this would just equal the natural log of this, right? That's all it would equal. And but we have 4 here, so instead it's 4 times the natural log of 1 plus x and plus c1. So that's the integral of the right side. And so we rewrite it, and this is what we get. And here what we could do here is, remember from logarithmic rules that if you have a constant in the front, or you have a constant here as an exponent, you can move it to the front. Well, we have a constant in the front, so we could just move it to the top here. So we'll get ln of absolute value of 1 plus x times the constant of 4, or to the power of the constant of 4 plus c1. And here, to remove the logarithm, easy trick again, you just get rid of the e. Or sorry, you just add an e to this side. And remember, there's a relation, like I said in the last video, between the exponential function and the logarithmic function, which is why you can remove the logarithmic function here as long as you add the exponential function to the right side. After doing that, we get this e to the natural log of 1 plus x, absolute value of 1 plus x to the power of 4 plus c1. And now we can separate these. Again, remember, this, when you multiply two functions like this, two exponential functions, their exponents just add, which is what you got here, right? If you were to multiply this with this, you would just get one singular e with the exponents being added, this plus this, which is what you have in the previous. But now we're separating them to go back to the previous function. So you would get e to the c1 times this, and then now it's separate, right? Because again, you would multiply these, so you would just get this, but we're simplifying. So you get this, or we're expanding a little bit to be able to deal with it in a more detailed manner. Because the more parts you have, the more you can simplify, the more you can do things with them, and it's better to operate that way. Now, to remove the absolute value, remember, absolute value, to remove it, just make it equal to plus or minus. Absolute value is always positive. That's all it means. So to remove that, you just set this equal to plus or minus. And this entire function, so there's two things here you have to look at in this line over here. This, in of itself, is just a constant, again, like I said in the last video. C1 is a constant. E is just a number. It's an exponential number. A constant to a constant is always going to give you a constant, right? Plus or minus, it doesn't really matter. Negative or positive, it's a constant regardless. Now, keep that in mind while I tell you about this one, because this is important too. Remember that there's a relationship between e and the natural log function, right? Which is why if you take e to the natural log of something, you could just cancel out the e and the natural log. They just cancel each other out, and you're just left with whatever you had as a natural log over here. Like, for example, right here. So whatever was in the brackets or parentheses, you're left with over here. And now we get y is equal to plus or minus e to the c1, e to the constant, times 1 plus x to the 4. Now, like I said, we could just set this equal to a constant, so define it as a constant. Make sure you write that you defined it as a constant, otherwise you replacing this with just a c is just weird. So y is equal to c times this entire thing right over here, And then final answer, we could drop the absolute value. And you'll be left with c times y is equal to c times 1 plus x to the 4th. And this is the final answer. So you start from here, you end up here, and it's pretty cool. And again, it's really cool how you could just separate these at the dx to this side, and actually it turns into an integration of its own. So that's really cool.